Hey everybody, so this is a video on AI agents and specifically the paper analysis of MechAgents, large language multi-model, multi-agent collaborations. And so I figure we'll start here with my agent, which is currently generating a summation for me of this particular article that we're looking at. And that we're going to examine. And then so it's a rather long article, and I've read through it multiple times. But rather than go through the full article, I figured I would just let my agent here do the work and talk to us a little bit more abstractly about this paper. So, as far as the abstract of the paper goes, the paper MechAgents addresses the challenge of solving mechanics problems using numerical methods. And the major thing here is that this particular problem, solving mechanics problems using numerical methods, is typically a human expert problem. It requires mathematics, critical thinking, a lot of elements to solve mechanics problems very specifically. And so these researchers have created, so their study explores the potential of organized multi-agent modeling frameworks powered by a state-of-the-art general-purpose LLM, GPT-4 in this instance, for solving elasticity problems using finite element methods. The agents, each with a unique profile, communicate and collaborate to perform tasks. The experiments demonstrate the benefits of self-correction and mutual corrections among agents, highlighting the capability of these models in problem solving and error correction with elasticity problems. And so that's the general gist here of the paper. And then the impact and applicability. This research introduces a novel approach to solving mechanics problems, traditionally a domain requiring high levels of human expertise. By integrating LLMs into a multi-agent framework, the study opens new avenues for the automation of complex problem solving and engineering, showcasing the ability of AI to not only assist, but also enhance human capabilities in this field. The potential of these AI systems to self-correct and learn dynamically suggests significant improvements in the efficiency and effectiveness of solving complex engineering problems. The methodology's applicability to a range of mechanics problems, coupled with its ability to incorporate various data types and models, makes it a significant step forward in the field of AI-assisted engineering and science. The approach also underscores the growing importance of AI and interdisciplinary research, where it can offer insights and solutions that may not be immediately apparent through traditional methods. And so the big thing to me why this caught my attention, this paper, for two reasons. The first one is that it involves AI agents, which is big on my mind right now. And then the second is that the way and the mechanism that they're using these AI agents. So I've had for about a year now the vision that a very specific path forward, and it seems like I my entire path that I've kind of thought that would be the best way forward is shaking out. So I'm just kind of patting myself on the back a little bit on that, but I want to highlight that because I've made videos throughout this whole entire year highlighting every single aspect of these things. And so what we're seeing now is reinforcement learning, agent-based learning, and like swarm agents very specifically, and kind of swarm agents where you have kind of a model of experts, but less than a model of experts. You have like a hierarchy of agents, right? Like you have like your worker bees, and you have agents that do different tasks, and then you have like kind of a super agent at the top that is like the brain that is like it overlooks things. It's the supervisor. No one wants the supervisor, but there's a reason why supervisor exists, right? And so to me, those elements have been the key to all of this, and we're seeing that play out more and more, right? Like the goal isn't to like create a singular bot that could like do anything. The goal is to create a brain, and then that brain could have control of multiple individual bots, and then the individual bots can do different things. Like you have an individual bot that's very good at specialized task A, individual bot that's very good at specialized task B, and the brain controls A and B separately. That's just the best way all around to me, that it's always seemed that these things break down. And then so as we're moving into the reality of AI agents, and as we're seeing here kind of again with my agent, and then so just highlighting it as well just so it's obvious, with my AI agent, the very first thing that I had it do was I had it go and try to research this paper online. But so this paper just came out today, and then so it's when my agent first tried to research it, it couldn't pull the actual paper itself. So I gave it the paper, and then it spit out the analysis. So there's still a little bit of human assistance there, and the agents still have some work to do, right? Like, so to me, all of this research, what we're talking about now, what we're looking at now, this is all generation one of agents. But I think like this time period that we're in right now is a very significant time period. We're in a major transition period, and I don't know how this is going to go. So the bottom line here is that we're at the point now where I can get, or anyone can get, AI models and AI agents to do tasks that have typically been within the human domain that require human logical thinking and thought processes and multiple steps and tasks to put together. I can flat out create AI bots that do these things. What does that mean for society as a whole? I don't know. I'm not the one to answer that. Like my stated overall opinions on that, I think that we should move to a UBI system immediately, and I think that that's the best way to avoid destruction all around with all of this. Is that going to happen? I think not. Like, I don't. So, but I think that the very first step is discussing these things and framing these things and understanding that like this is not science fiction. Like what we're looking at right now is now science reality. I can in the status quo and research in the status quo, and these papers that we're looking at in the status quo are dealing with AI that can replace typically human tasks. So in this instance, this is very specifically mechanics problems, like very specifically like automation, warehousing, mechanics, engineering. AI is now capable of doing those things. What does that mean for society overall? Again, like I'm not the one to say what this means. I'm just the one to point out the research and to continue the research in this area. Like I don't think that there's a way to stop this train at all from this point, right? Like so, we're now at the point where agents can create agents and agents can go do things and agents exist and so we're in gen 1 of agents right now. Very quickly we'll be in gen 2 and then it snowballs from there, right? Like that's it. Like it's a like the curve goes like almost like a straight line up from here. I don't think that's what people understand with this. Like once you get agents, then agents can build agents, and then it's just an exponential growth curve. And there's no stopping it. Like there's like I mean, you could not want it to happen. Like you could cry about it. It's going to happen. Like, what does that mean, and how do we deal with that? Like, and it's not one person, right? Like it's not like I'm not driving this. Like it's like it's driving itself. The car is driving itself at this point. Is the literal reality that people need to face. So, and the car is not going to stop driving itself. And so, how do we deal with these things? It's the kind of the challenges that we should be looking at and facing within these types of things. If you like this type of content, please like and subscribe. I'll leave the link to and the description to this paper in the description of the video as well. Thank you very much.